Welcome to the Deep Dive. This is where we take a whole stack of, well, compelling sources, we sift through them, and we try to pull out the most vital nuggets of knowledge, those key insights, and often, yeah, some genuinely surprising facts. It's all designed to help you get truly well informed. Today, we're plunging into a topic that, sadly, touches nearly every one of us, either directly or indirectly. We're talking about the relentless march of memory loss, the really devastating impact of Alzheimer's disease, and, that long, often just heartbreaking search for effective treatments. It's such a universal concern, isn't it? This kind of profound fear of losing our memories or watching loved ones slowly fade away, their identities just slipping through their fingers like sand. And
Yeah.
for far too long, the scientific community, despite just immense effort and resources, has faced such an uphill battle, really struggling to find a cure or even, a truly meaningful way to slow its progression.
It really has. The fight against Alzheimer's has been one of humanity's most persistent and, frankly, heart-wrenching battles. Despite decades of dedicated research, the current landscape of treatments, well, it offers only marginal benefits.
Marginal, right?
Yeah, typically just nudging the clock back slightly, maybe delaying things a bit, and they often come with some pretty severe side effects.
Mm.
This grim reality has left millions, literally millions of patients and their families searching for real, transformative hope.
And that's precisely why what we're about to dive into today is creating such an extraordinary buzz. It's really stirring things up across the scientific world. Imagine a surprising discovery, right? An element that's far more familiar to us for its role in, say, batteries, like in our electric cars.
Right, or maybe in psychiatry.
Exactly, or perhaps as a well-established mood stabilizer.
Yeah.
But now it's emerging as this powerful, really unexpected contender in the fight against Alzheimer's. We are talking about lithium.
Lithium, yeah.
Our deep dive today is built upon truly groundbreaking research. There's this meticulous decade-long study from Harvard Medical School, published in the incredibly prestigious journal Nature.
Which is a huge deal in itself.
Absolutely. And it's complemented by corroborating reports and, pretty enthusiastic coverage from outlets like SBS News, New WSC, Science Times, and Biospectator. So our mission today is to take you on a journey, really, to unpack these findings, to reveal those aha moments that genuinely shift our understanding, and to help you grasp what this could mean for the future of brain health and ultimately, well, for you. So, okay, let's unpack this. Could the key to preventing and maybe even reversing the devastating effects of Alzheimer's be something as fundamental and, well, ubiquitous as lithium?
It's a provocative question, certainly. And the research, as we'll explore, it offers incredibly compelling and, dare I say, optimistic narrative. The scientific community globally is indeed taking significant notice, and for very, very good reason. It suggests a fundamental reevaluation, really, of how we even understand this disease.
Okay, so before we dive headfirst into the promise of lithium, let's maybe paint a clearer, although, it's a sobering picture, of the current landscape of Alzheimer's. It truly is a silent scourge, isn't it? The global burden of this disease is just absolutely staggering. It touches every corner of the planet.
It is devastatingly so. Alzheimer's stands as the most common form of dementia. Currently, it's affecting over 55 million people worldwide.
55 million, wow.
Yeah. To truly grasp the scale of this, just imagine the entire population of, say, South Korea or nearly all of England grappling with this condition.
Yeah.
But the numbers alone, they don't convey the full impact.
Yeah.
Beyond the individuals diagnosed, you've got hundreds of millions more family members, friends, caregivers whose lives are just profoundly altered. They essentially become secondary victims and bearing immense emotional, physical, and often financial burdens. And as our global population ages, Alzheimer's has rapidly escalated into one of humanity's greatest health threats. It's like a ticking demographic time bomb. Many of us, probably most of us listening, know someone, a parent, a grandparent, a cherished friend who has been touched by this disease. You watch their memories, their sense of self, their independence slowly just inexorably erode.
Yeah, it's heartbreaking.
It truly highlights that profound concern we all share about aging gracefully and, maintaining our cognitive faculties, our very essence, throughout our lives. The World Health Organization estimates the global cost of dementia is already over $1 trillion annually,
A trillion.
and is projected to double by 2030. And that figure, that doesn't even begin to quantify the immeasurable human suffering involved.
It's hard to even comprehend. So, okay, to understand how lithium might offer this new path forward, we first need to really grasp the enemy itself, the pathophysiology of Alzheimer's disease. For those of us who think we know the basics, what's maybe the most crucial, perhaps even surprising thing we've learned recently about what's actually happening in the Alzheimer's brain?
That's a great question, because while the core mechanisms, the plaques and tangles, have been known for a while, the nuances are constantly evolving. At its heart, Alzheimer's is a complex neurodegenerative disease. It's primarily characterized by the accumulation of two abnormal proteins in the brain.
Right, the famous ones.
The famous ones, exactly. First, you have amyloid beta, or AT, which forms those distinctive sticky plaques outside of nerve cells. And second, there's tau protein, which forms twisted, tangled structures known as neurofibrillary tangles inside the nerve cells.
Okay.
Now, AB protein is actually quite fascinating. In its normal, healthy state, it plays a protective role for nerve cells. It assists with things like synaptic plasticity and communication. It's an integral part of the brain's natural functioning.
So it's not inherently bad.
Not inherently bad, no. However, for reasons scientists are still, fully unraveling, it can begin to misfold and aggregate abnormally. It forms these dense, insoluble plaques. When these plaques accumulate, they act like internal saboteurs, really. They disrupt normal neural signals, interfere with the intricate communication pathways between brain cells, and they trigger widespread inflammatory responses in the surrounding brain tissue. Ultimately, this leads to significant nerve cell damage and death.
So the plaques are the first big problem.
They're typically observed accumulating early in the disease, often many, many years before clinical symptoms even appear. But simultaneously, you have the tau protein. Now, tau normally functions like a structural scaffold. It helps stabilize microtubules within neurons.
Microtubules,
Yeah.
like tiny transport tracks inside the cell.
Exactly. Think of them as the railway tracks that transport essential nutrients and components throughout the nerve cell. Well, in Alzheimer's, tau becomes hyperphosphorylated.
Hyperphosphorylated. Okay, that's a mouthful. For those of us not in the lab every day, can you give us a super quick, maybe even a visual explanation? Does it mean it's suddenly overloaded with like sticky bits that make it collapse and tangle, sort of like a bridge breaking down?
Precisely. You've hit on a perfect analogy there. Imagine those microtubules as perfectly straight, well-maintained railway tracks, right? And the tau protein is like the ties or fasteners holding them together, keeping the tracks stable and aligned.
Okay.
Hyperphosphorylated means that too many phosphate groups attach themselves to the tau protein. These extra phosphate groups fundamentally change the protein's structure. They make it unstable, causing it to detach from the microtubules.
So the ties break.
The ties break, exactly. Without their stabilizing ties, these railway tracks fall apart. They collapse into a jumbled mess, much like that bridge breaking down.
Yeah.
The detached tau proteins then clump together, forming those neurofibrillary tangles inside the neurons.
Inside the cell itself.
Yes. And these tangles essentially clog up the cell. They impede its ability to transport essential nutrients and vital components, which leads to the ultimate dysfunction and eventually the death of the nerve cell. So it's really a double whammy.
Yeah.
You've got the external plaques disrupting communication and the internal tangles destroying the cell's transport system.
Wow. So plaques outside, tangles inside, both relentlessly damaging the brain. Given this understanding, what are our current treatment options? And maybe more importantly, what have we learned about the limits of those efforts?
The current state of Alzheimer's treatment, unfortunately, remains quite stark. There are simply no cures.
No cures. Still
no cures.
right.
Our existing drugs primarily focus on managing symptoms or attempting to slow the rate of cognitive decline, but they cannot reverse the damage that has already occurred, nor do they halt the disease entirely.
Right.
For instance, in recent years, we've seen the approval of these AO-targeting drugs like donanemab, that's Kysunra, in 2023, and lecanemab, known as Leqembi, in 2024.
Yeah, those made headlines.
They did. They were initially heralded with a degree of hope because they're actually designed to clear amyloid plaques from the brain. However, their benefits, while technically disease-modifying, are quite marginal.
Marginal, how so?
Well, clinical trials show they typically slow memory loss only slightly, maybe by about 20–30% over 18 months in some studies. And crucially, they do not restore lost cognitive function.
Ah, okay. So they don't bring memories back.
No. Patients might experience a modest delay in progression, but they aren't getting their memories back.
So they might just nudge the clock back a tiny bit, maybe give you a few extra months of slightly better function, but they aren't turning it backward. And the cost, I mean, both financially and in terms of side effects, that's significant, right?
Exactly. And to add to that, these drugs come with notable and, at times, quite severe side effects. We're talking about risks such as ARIA, that's amyloid-related imaging abnormalities.
ARIA. Okay.
Yeah.
What does that mean practically? Like actual side effects?
Yeah, practically it can manifest as brain swelling, that's ARIAE, and even small brain hemorrhages or bleeds, that's ARIH. You can see these on MRI scans.
Swelling and bleeding in the brain. That sounds serious.
It is. These side effects necessitate really careful monitoring with regular MRIs. They can be quite serious, and they inherently limit their widespread application, especially for patients with certain pre-existing conditions or genetic predispositions. Right. So this means that while they represent a scientific step forward, targeting a specific pathology, they are far from the comprehensive, safe, and easily accessible solution we desperately need.
Which makes sense why everyone's looking for something new.
Precisely why the scientific community is so actively seeking entirely new approaches. It creates this profound sense of urgency and, well now, thanks to this new research we're discussing, a palpable glimmer of hope that a truly transformative treatment might actually be on the horizon. Science Times, for example, in its coverage, really emphasized this critical need, highlighting that while these plaque-clearing drugs are a start, the next frontier absolutely must address the broader mechanisms of the disease with fewer compromises.
And this brings us perfectly to our surprising contender. Because when you think of a groundbreaking discovery for brain health, you probably don't immediately picture lithium.
Probably not, no.
It often evokes images of batteries, like we said, or perhaps a rather intense psychiatric medication. But that's where our journey takes us today. So let's introduce this, well, humble element.
Lithium really is a remarkable element, and its story in medicine is equally compelling. Chemically, it's the lightest metal element on the periodic table. It's a silvery white substance, atomic number 3.
Number 3, okay.
And it's not some exotic compound confined to a high-tech lab either. Lithium occurs naturally in various forms all across our planet. You find it in rocks, in the vast expanses of our oceans. Seawater contains, maybe 0.1 to 0.2 parts per million.
Tiny amounts.
Tiny amounts, but it's there. And even in trace amounts within everyday foods that we consume regularly, things like grains, cabbage, tomatoes.
Really? In
Yep. And yes, it's even present in minute quantities in our drinking water, depending entirely on the geological composition of the region you live in. It's far more ubiquitous and integrated into our natural world than many people realize. It's a fundamental part of the Earth's crust.
What's truly astonishing, though, when we look at the history of lithium, is this completely new light it's now being cast in. What changed in our understanding that brought it back to the forefront for Alzheimer's? Because lithium isn't new to medicine, is it? It has a fascinating, if sometimes maybe challenging, history.
You're absolutely right. Its medical application actually traces back to an almost accidental discovery in the 1940s by an Australian psychiatrist named John Cade.
Accidental.
Pretty much. He was experimenting with lithium salts on guinea pigs, initially thinking they might have a sedative effect, and he noticed these profound mood-stabilizing effects. From there, its compound, lithium carbonate, became a cornerstone in the treatment of bipolar disorder, which used to be called manic depressive illness.
Right, for bipolar. I knew that.
Yeah. For decades, it has been extraordinarily effective in stabilizing mood, preventing those severe manic and depressive episodes, and providing much-needed relief for millions of individuals suffering from these severe mood swings. It's an established, effective presence in clinical practice, often considered one of the most effective treatments for bipolar disorder. Many people hail it as a lifesaver. However, and this is a crucial distinction that has historically limited its broader application, the concentrations of lithium typically required to treat bipolar disorder are relatively high.
Okay, high doses.
Relatively high doses, yes. And at these levels, particularly with long-term use, lithium carbonate can lead to significant side effects. Things like kidney or thyroid dysfunction, as well as gastrointestinal issues, tremors.
Right, the side effects are well known.
They are. And this necessitates careful monitoring and management by healthcare professionals, making it a powerful but, somewhat delicate tool to use.
So it's effective for mood, absolutely, but not without its challenges at those higher doses. But now it's taking on a completely new promise, right? One that goes way beyond mood stabilization and into the realm of neuroprotection for Alzheimer's.
Precisely. Despite those historical challenges associated with high-dose lithium carbonate, This new research indicates that lithium is now emerging as an incredibly powerful candidate for Alzheimer's prevention and treatment, especially when delivered in a novel, low-dose form.
Okay, low-dose form. That sounds key.
It's absolutely key. This development signifies what many in the scientific community are calling a truth moment, maybe, in humanity's fight against major health threats like neurodegeneration. Biospectator, for example, highlighted this very point, calling it a potential paradigm shift in our approach.
A paradigm shift. That's strong language.
It is. The core finding is that this humble element, often overlooked in the context of neurodegenerative diseases, might just hold the key to a much-needed breakthrough. This deep dive, well, it's going to reveal exactly how and why lithium is making such a significant splash, and why scientists are now so cautiously optimistic, viewing it not just as a psychiatric drug anymore, but perhaps as a fundamental neuroprotective agent.
And the source of all this excitement, the real engine behind this new understanding, is this truly groundbreaking study from Harvard. Tell us about this research, because it wasn't just a quick look, was it? It was a meticulous decade in the making, really laying a deep foundation for these new insights.
Yes, this wasn't a fleeting observation or some short-term project. This was a rigorous, meticulously designed 10-year study. It was spearheaded by Professor Bruce Yankner, who's a leading figure in genetics and neurology at Harvard Medical School.
Yankner, okay.
And Professor Yankner is no stranger to Alzheimer's research. He's actually credited with first identifying the toxicity of amyloid beta protein, aggregates those very plaques we discussed in the context of Alzheimer's way back in the 1990s.
Wow, so he's been in this field for a long time.
A very long time. He has a profound understanding of its core mechanisms. The significance of this new work is really underscored by his publication in the international journal Nature in 2025. And as you know, Nature is one of the highest impact scientific journals in the world, generally reserved for truly transformative discoveries.
Absolutely. Top tier.
Top tier. And what lends even greater weight and credibility to these findings is that they weren't just theoretical or confined to a single model. They were rigorously confirmed through both controlled mouse experiments and the in-depth analysis of human brain tissue from a diverse cohort. That provides a strong dual foundation for the research that's frankly difficult to dispute.
Okay, so a decade of work published in Nature, confirmed in both animals and humans. That's definitely serious science. And this study, it fundamentally fifths our understanding of lithium's role in the brain, right? Presenting it not just as a treatment, but as an essential, naturally occurring element for fundamental brain function.
Absolutely. The research introduces a profound paradigm shift. It tells us that lithium isn't merely an exogenous substance, something you administer for a therapeutic effect, like a typical drug. Instead, it suggests lithium is an essential, naturally occurring substance that plays a crucial, continuous role in fundamental brain function, almost like a vital mineral for brain maintenance.
Like calcium for bones or iron for blood.
That's a great way to think about it, yes.
Yeah.
The study elaborates on its multifaceted importance, showing it's involved in several key processes. It aids in the formation of myelin.
Myelin, that's the insulation around nerve fibers.
Exactly. That critical protective sheath around nerve fibers, think of it as the insulation around electrical wires. It ensures efficient and rapid neural communication. It also supports the proper function of microglia.
Microglia, the brain's immune cells.
Correct. They act like tiny, vigilant cleanup crews, effectively removing cellular debris, damaged cells, misfolded proteins, thereby maintaining overall brain health. Furthermore, lithium is vital for maintaining the intricate connections and communication pathways between neurons, ensuring the smooth flow of information and cognitive processing throughout the brain.
Okay.
And quite intriguingly, it influences the expression of something called the rest protein.
Ah, yes. You mentioned the rest protein earlier. Can you elaborate a bit more on its role? Why is its connection to lithium so significant for understanding dementia?
Certainly. The rest protein, it stands for RWE1 silencing transcription factor, is a master regulator of gene expression in the brain.
A master regulator, like a conductor.
It's exactly like a conductor, orchestrating which genes are active and which are silent in neurons, particularly in response to stress. It plays a critical role in protecting neurons from various forms of stress and damage. It essentially acts as a cellular guardian that promotes neuronal survival and function.
Okay, so it's protective.
Very protective. And a decrease in the activity or levels of this rest protein has previously been strongly linked to neurodegenerative processes and various forms of dementia, including Alzheimer's. So the fact that lithium influences this crucial protective protein means it's deeply embedded in maintaining brain resilience. It directly impacts a known pathway involved in neurodegeneration. If lithium helps maintain rest levels, it's basically helping keep the brain's defenses strong.
Wow. Okay, this sounds like a fundamental building block for brain health. But the core discovery here, the really central hypothesis, is this lithium deficiency idea. This is where it gets really, really interesting how Alzheimer's might be, in a sense, literally stealing our lithium.
That's a profound way to put it, and it really is the central revelation of the study. The core hypothesis put forth by Yankner's team is that the human brain operates with this delicate, finely tuned ecosystem of essential metals, lithium, iron, copper, others, all in a carefully maintained balance that's crucial for optimal function.
A metal ecosystem, huh?
Yeah.
Yeah.
And their groundbreaking proposal is that the very formation of plaques, which we know are central to Alzheimer's, disrupts this crucial balance by essentially capturing or removing functional lithium from the free, active pool in the brain.
Capturing it, like taking it out of commission.
Exactly. This depletion of available lithium, they argue, directly leads to the memory loss, the cognitive decline, and other debilitating symptoms characteristic of Alzheimer's disease. It's a mechanism that fundamentally redefines how we view the disease's progression. It's not just about the plaques causing damage. It's about the plaques causing a deficiency that causes damage.
That's a huge shift. And how did they confirm this, well, shocking idea in human brains? What kind of evidence did they gather? Because that sounds like a big claim.
It is a big claim, and their approach was remarkably thorough and comprehensive, which gives the hypothesis immense weight. The study involved a meticulous examination of 27 different metal levels in the brains and blood of 285 deceased individuals.
285 people.
Yes, and this cohort was very carefully selected to span the entire spectrum of cognitive health. They had people who were cognitively normal, individuals with mild cognitive impairment, which is often a precursor to AD, and then all the way to patients with severe Alzheimer's disease.
So the whole range.
The whole range. And the results were quite stark, definitive, and incredibly compelling. Lithium was the only metal among all 27 measured whose levels consistently and significantly changed in direct correlation with the progression of cognitive decline.
The only one out of 27.
The only one. This wasn't a subtle shift either. Specifically, they found that lithium levels in the prefrontal cortex, which, as you know, is a vital brain region for memory, decision-making, executive functions, personality.
Yeah, really important area.
Critically important. Those levels were an average of 36% lower in individuals diagnosed with severe Alzheimer's disease compared to healthy, cognitively normal individuals.
36% lower. That's substantial.
It's very substantial. And even in those with mild cognitive impairment, lithium levels were notably reduced by 23%. This strong, direct correlation across the entire spectrum of cognitive health suggested a profound and integral link between lithium availability and the disease.
So lithium levels drop significantly as cognition declines.
Okay.
But the natural follow-up question then is, if the lithium levels are lower in the brain tissue overall, where did it go? I mean, it didn't just vanish into thin air, did it? This is where that trap theory comes into play, which is a truly, well, disturbing mechanism.
That's the truly intriguing and frankly concerning part, and it's where this trap mechanism becomes terrifyingly clear. The researchers made a crucial, almost unbelievable discovery. They found that the plaques themselves within the brains of Alzheimer's patients contain 3 times more lithium than other healthy regions of the brain.
3 times more lithium inside the plaques.
Inside the plaques themselves. This led them to a clear and deeply unsettling conclusion about the mechanism. As proteins begin to misfold and accumulate in the brain during the early stages of Alzheimer's, they don't just sit there inertly. Instead, they actively bind with and sequester lithium through an electrostatic reaction.
Okay, electrostatic reaction for the lay listener. Can you give us a simple analogy? Is it like, I don't know, tiny magnets attracting each other, and the plaques are just really strong magnets for lithium?
Exactly. That's a perfect analogy. Think of it just like tiny, strong magnets. The plaques carry a specific electrical charge and structure that strongly attracts and binds to the lithium ions, which also carry a charge.
Okay.
This powerful electrostatic attraction effectively traps the lithium within the plaques. It locks it away and renders it unavailable for its normal, essential functions within the brain cells. It's like a critical nutrient being siphoned off and literally locked away in a vault by the very structures that are causing the disease. It's unable to do its vital job.
Well,
So it's not disappearing. It's being actively hijacked and sequestered by the accumulating plaques.
so the very plaques that cause so much direct damage are also, in a sense, actively hoarding this essential element, making the problem even worse and creating this devastating cascade. This truly sounds like a vicious cycle.
It absolutely is a self-reinforcing negative loop, a truly vicious cycle that accelerates the disease.
Yeah.
Just imagine it. The initial accumulation of ADA proteins begins to trap the available lithium, actively removing it from circulation.
Right.
This leads to a decrease in the levels of free, functional lithium in the brain. This deficiency doesn't just stop there. It then accelerates the further production and aggregation of EA itself.
Oh, so less lithium makes more plaques.
Exactly, which leads to even more plaques, which in turn trap even more lithium. Simultaneously, this lithium deficiency speeds up the hyperphosphorylation and entanglement of tau proteins, the tangles inside the cells.
So it makes the tangle problem worse, too.
Yes, further exacerbating the neurodegenerative process and intensifying the symptoms of Alzheimer's disease. The study explicitly found that these lower lithium levels were directly linked to the onset of memory loss and other characteristic AD symptoms. But it doesn't stop there either.
There's more.
Yeah, they also observed that lithium deficiency causes myelin, that insulation we talked about, to become thinner and damaged. This further impairs the vital communication pathways between neural cells, slowing down thought processes and memory recall.
Okay, so communication breaks down more.
Right. And even on a genetic level, they discovered that lithium affects the expression of the APOE gene. Specifically, it influences the protective function of the APOE2 allele and the risk associated with APOE4, which is, as many listeners will know, a well-established major genetic risk factor for Alzheimer's.
Wow. So it hits on genetics, myelin, tau, and amyloid production.
Exactly. It's not just a single point of failure. It's like a multi-pronged attack on brain health, orchestrated by this spiraling lithium deficiency. NewSS, one of the sources, specifically highlighted this interconnectedness, marveling at how one simple element could influence so many disparate pathways of the disease.
That's a really comprehensive picture of the damage. It sounds like a cascading failure, where one problem directly feeds into several others, making everything worse. But to truly confirm this cause and effect, you really need controlled experiments, right? So what did the mouse models show when they actually replicated this lithium deficiency? Did it cause the same problems?
The mouse model validation was absolutely critical, yes, for confirming this cause and effect relationship, taking the observations from human brain tissue into a controlled experimental setting. The researchers conducted meticulously controlled experiments where healthy mice were put on a diet with a significantly reduced lithium intake specifically, a drastic 92% less lithium compared to their normal diet.
92% less. Okay, that's a big drop.
A very big drop. And the outcomes of these experiments strikingly mirrored the observations found in human brain tissue and correlated directly with AD symptoms, providing really compelling evidence. The mice on the low lithium diet showed a marked reduction in their brain lithium levels, just as expected, which in turn directly accelerated the formation of plaques exactly as the hypothesis predicted. Their microglia, which, as we discussed, are supposed to be the brain's immune cleanup crew.
Right, the little vacuum cleaner.
Yeah, they transformed. Instead of their usual protective role, they became pro-inflammatory cells. They were less effective at clearing plaque and actually more prone to causing damage themselves.
So the cleanup crew started making a mess.
Sort of, yeah. They became part of the problem. These mice also experienced a profound loss of synapses, those critical junctions where neurons communicate, as well as damage to axons and myelin, that protective sheath.
Okay.
All of this led to significant declines in cognitive function and memory. Essentially, these mice began to exhibit the classic, debilitating symptoms of Alzheimer's disease. This whole suite of outcomes in the experimental mice directly and powerfully confirmed that a deficiency in lithium promotes the progression of Alzheimer's disease. It established a direct causal link.
That's incredibly compelling evidence, seeing the direct link in a controlled environment that lithium deficiency causes these Alzheimer's-like symptoms in mice. So, okay, if lithium deficiency is a key problem, the next logical step is, well, how do you address it? But as we discussed earlier, previous studies on lithium and cognition had pretty mixed or inconsistent results, often because of the side effects of that high-dose lithium carbonate used for bipolar. So why is this different? What's the breakthrough here?
This brings us to a truly crucial point, and it's where the ingenious aspect of this new research really comes to light. The form of lithium matters.
Hugely.
Okay? Previous studies, particularly those attempting to use lithium for cognitive benefits, often employed lithium carbonate. That's the standard treatment for bipolar disorder. However, the Harvard study revealed a critical flaw in this approach specifically for Alzheimer's. Lithium carbonate when introduced into the brain environment where plaques are present, is easily bound by those very plaques we discussed.
Ah, so the plaques trap the carbonate form too?
Yes, this essentially limits its therapeutic effect because it gets tracked by those magnets before it can even reach the brain cells where it's needed for normal function. Plus, as we mentioned earlier, lithium carbonate requires relatively high doses to be effective for mood stabilization. And that carries those well-known risks of kidney and thyroid toxicity, making it pretty unsuitable for long-term preventative use in a broader population, especially older adults.
Right, you wouldn't want to give everyone high-dose lithium just in case. So, okay, what does this all mean for us? If lithium carbonate isn't the answer for Alzheimer's, what is? This is where the true game changer comes in, this new compound you mentioned, right?
Exactly. This is where lithium orotate steps forward as the truly novel solution. It's a compound that promises to overcome the limitations of its predecessor, lithium carbonate. Lithium orotate is a unique compound formed by combining lithium with orotic acid.
Orotic acid. What's that?
Orotic acid is a natural compound actually found in milk and other things. The genius of this combination lies squarely in the orotic acid component. It acts as a kind of sophisticated shuttle or molecular chaperone for the lithium.
The shuttle.
Yeah. It significantly helps lithium ions cross the cell membrane more effectively. And crucially, it seems to allow it to bypass that trap we talked about.
Okay, so it gets past the magnets.
It gets past the magnets, allowing the lithium to reach the brain cells where its essential functions are desperately needed, rather than being sequestered by the plaques. But here's the truly groundbreaking part, the part that makes it so exciting for potential human application.
Yeah.
Lithium orotate achieves its profound therapeutic effects at an astonishing 1,000 times lower concentration than the lithium carbonate typically used for bipolar disorder.
1,000 times lower. Did I hear that right?
You heard that right, 1,000 times lower concentration. This drastic reduction in dosage fundamentally transforms the risk profile. It virtually eliminates those serious concerns about problematic side effects on the kidneys and thyroid that have plagued high-dose lithium for decades.
Wow. That's incredible.
It really is. And interestingly, lithium orotate isn't an entirely new substance. It's actually already used in some brain health supplements, often marketed for cognitive support or mood. So it's a familiar, albeit maybe niche, compound in the wellness sphere.
So it's already out there kind of under the radar.
Kind of under the radar, yeah. Which could potentially accelerate its path to formal clinical trials because there's already some history of human use, albeit not for Alzheimer's specifically.
That's a monumental difference in dosage, 1,000 times lower. That's not just remarkable, it's potentially revolutionary for safety. So, okay, what kind of results did they see when they actually administered this new form of lithium, the orotate form, to the mice with Alzheimer's? Were they able to, reverse the damage?
The results were truly dramatic. I mean, they represent a significant leap forward in our understanding of potential Alzheimer's treatment. When lithium orotate was administered to mice that had already developed symptoms mirroring human Alzheimer's, the findings were nothing short of striking.
Okay, let's hear them.
All right, first, there was a significant and measurable decrease in both plaques and tau tangles, those hallmark pathologies of the disease. They went down.
So it cleared the junk, basically.
It cleared the junk, exactly. But beyond just reducing these pathological markers, the treatment led to a remarkable restoration of memory function.
Restoration, not just slowing decline, but actually bringing memory back.
Bringing memory back. This was observed even in older mice that had already developed advanced Alzheimer's-like cognitive deficits. This suggests a potential for not just slowing the disease, but actively reversing existing damage, which is frankly a monumental leap from anything currently available.
That is huge.
It gets better. The study also showed that maintaining stable lithium levels from a young age through lithium orotate prevented the onset of Alzheimer's disease altogether in the mice,
Prevention, too. Wow.
offering a clear path for potential prophylactic intervention. And critically, from a safety perspective, lifelong administration of lithium orotate in these mice showed no observable toxicity at these low doses.
No side effects, even lifelong.
No observable toxicity, which is an incredibly encouraging sign for future human trials. Professor Yanker himself, reflecting on his decades of research in this field, noted that lithium broadly affects such diverse AD symptoms, from the amyloid and tau pathology to myelin integrity, microglial function. He stated he had personally never seen such a broad impact on the disease's various symptoms from a single intervention in his entire research career.
Never seen anything like it.
That broad spectrum efficacy is what truly sets it apart.
That's absolutely huge. Preventing the disease, restoring memory function, targeting multiple pathologies, and no observable toxicity. That truly changes the entire conversation around Alzheimer's treatment. And this isn't just about targeting one aspect of the disease, then, like the current clearing drugs focus on. It sounds like a much more holistic approach.
No, it's definitely not just one target.
Hmm.
And that's precisely why many experts, like Ashley Bush, who's a neuroscientist at Melbourne University, explicitly called the discovery breakthrough.
Breakthrough.
Yeah. He contrasted this approach directly with existing AM-targeting drugs, stating, and I'm paraphrasing slightly here, while we've only recently gotten the first disease-modifying drugs for Alzheimer's, they only target one thing, amyloid plaques. This new approach targets all major pathologies of the disease.
All major pathologies.
All of them. This is such a crucial distinction and carries profound implications. Current A-targeting drugs, they're designed to clear plaques. And while that's a step, they don't really address the other complex dysfunctions like the tau tangles, the myelin damage, or that microglial inflammation we talked about.
Right, they're single target.
They're a single target. Lithium orotate, however, appears to tackle the whole interconnected web of pathologies, from direct plaque and tangle reduction to myelin protection, improved microglial function, and even genetic regulation via REST and APOE. This multi-pronged holistic approach suggests not just slowing progression, which is what current drugs barely manage, but the potential reversal of existing damage. That would be a monumental leap, a true game changer in how we confront Alzheimer's. BioSpectator really emphasized that this wide-ranging impact is precisely what makes the findings so potentially revolutionary. Hashtag why this is different and what it means for you.
Okay, so this isn't just another incremental step forward. It really could fundamentally be a paradigm shift in how we approach one of humanity's most feared diseases. Let's really talk about what makes this so different and what it could mean for you, our listener, personally. Beyond the scientific marvel of it all, what are the real-world implications? What's the tangible hope it offers?
Well, one of the most significant and, frankly, exciting implications is the profound potential for early detection and prevention.
Early detection? How so?
The research strongly suggests that by precisely measuring brain lithium levels, which could potentially be done through less invasive methods down the line, maybe specialized blood tests, or more directly perhaps via cerebrospinal fluid analysis, or even specific brain imaging techniques in the future, we might be able to identify individuals at risk for Alzheimer's disease years, maybe even decades, before symptoms even begin to appear.
Wow, identify risk that early.
Yeah. Imagine being able to establish a target lithium level for prevention, similar to how we monitor and manage cholesterol levels for heart disease or vitamin D levels for bone health.
Like a routine checkup item.
Exactly. And this isn't just theoretical speculation. There was a robust Danish study back in 2017 that already observed notably lower dementia rates in regions with naturally higher lithium levels in their drinking water.
Really? So there's real-world data suggesting this?
Yeah, providing real-world epidemiological support for this very concept. Professor Yankner himself drew that powerful analogy we mentioned, stating that lithium, based on this research, should really be thought of as akin to other essential nutrients like iron or vitamin C, naturally present at biologically significant levels and critical for health. This completely redefines our understanding of lithium, doesn't it? Not just as a drug for a specific condition, but as a vital element in fundamental brain health maintenance.
That is a total reframing.
It suggests a future where preventative measures might be as simple as ensuring adequate levels of an essential trace element.
What's truly fascinating here is, well, the economic aspect. If this treatment pans out, if it proves successful in humans, it could be incredibly affordable, right? Which is such a stark contrast to many of the highly specialized, genetically engineered drug therapies we see coming out today, which often carry just exorbitant price tags.
Precisely. And this is a truly remarkable and potentially profoundly impactful aspect of this discovery. It's something that Nuthius, one of the sources, particularly highlighted, because lithium is a natural, unpatentable element. It cannot be monopolized by a single pharmaceutical company in the same way a synthetic drug molecule can.
Right, you can't patent lithium itself.
You can't. Which means that if proven effective in human trials, no single entity can corner the market and charge massive profits.
Yeah.
Professor Thomas Hijack from Dalhousie University, he's a psychiatrist not involved in the study but with deep expertise in mental health and pharmacology. He pointedly stated that no pharmaceutical company will profit from lithium. And he added that this level of evidence with such a safe pipeline is rare, and lithium is incredibly cheap.
Incredibly cheap.
Yeah. Now, this lack of patentability Admittedly, it does pose a challenge for large-scale pharmaceutical investment in those costly clinical trials because there's no exclusive profit incentive. We'll talk more about that. But ultimately, it means that if successful, this treatment could be incredibly accessible and affordable for people worldwide.
That's huge for global health.
It's a critical factor for a disease that affects so many across all socioeconomic strata. It offers genuine hope for equitable access to a transformative treatment rather than it being, exclusive to the wealthy. It's potentially a public health victory in the making, provided the trials proceed and confirm the findings.
And Alzheimer's, well, it often has a strong genetic component. We all know about genes like APOE4 increasing risk pretty significantly. How might this research play into our understanding of genetic predisposition? Could it perhaps offer new avenues for individuals with known genetic risks?
That's an excellent and crucial point. While Alzheimer's does indeed have a strong genetic component with certain genetic variants significantly increasing risk, it's also true that many individuals with these genetic predispositions never actually develop the disease, or perhaps develop it much later in life, sometimes seemingly defying the odds.
Right, genetics isn't always destiny.
Exactly. And this research could provide crucial clues as to why some individuals with these genetic predispositions remain dementia-free. It might link directly to their natural lithium levels, perhaps their unique genetic makeup influencing their ability to absorb and utilize lithium effectively in the brain, or maybe other factors that maintain this essential metal's delicate balance despite those genetic vulnerabilities.
So maybe lithium levels are protective even against bad genes.
It's a real possibility. It opens up an entirely new avenue for personalized prevention strategies. It suggests that even for those with high genetic risk, maintaining optimal lithium levels might offer a powerful protective mechanism, potentially mitigating or delaying the onset of the disease. It's a profound shift away from a purely deterministic view of genetic risk.
So, okay, it's potentially huge for Alzheimer's prevention and treatment, even for those with genetic risk. But is it only about Alzheimer's? Could this research imply broader cognitive benefits, maybe even for those without the disease, like for general brain health and vitality as we age?
Absolutely. The implications certainly seem to extend beyond just Alzheimer's treatment. The study also reveals something quite interesting. Even in cognitively normal individuals, higher concentrations of lithium in the brain correlated with better scores on specific memory tests and general cognitive function assessments.
Better memory even in healthy people.
Yes. Which strongly suggests that lithium plays a vital, ongoing role in maintaining normal brain function and general cognitive health, not just in combating disease. It could be seen as a fundamental neuronutrient, really essential for optimal cognitive performance throughout life.
Like brain fuel.
Sort of, yeah. Furthermore, there's a fascinating suggestion stemming from this that lithium orotate could potentially offer better outcomes for elderly bipolar patients compared to the standard high-dose lithium carbonate.
How so?
Well, by providing the necessary mood-stabilizing benefits, but at significantly reduced doses and, crucially, without the associated organ toxicity risks, it could dramatically improve their overall quality of life and potentially offer neuroprotective benefits concurrently, which is particularly relevant as bipolar disorder itself carries an increased risk of dementia later in life.
Interesting. So it could help them in two ways.
Potentially, yes.
Yeah.
The ripple effects of this discovery truly extend across various facets of brain health and mental well-being, offering a much more holistic approach than we previously considered.
This is all incredibly hopeful. I mean, it really paints a future where Alzheimer's might actually be preventable or even reversible using something relatively simple and accessible. But, as with any groundbreaking research, especially one involving a natural element with a complex history like lithium, there are always hopes, hurdles, and practical considerations that need to be addressed. What does the road ahead look like for lithium and Alzheimer's? Where do we go from here?
Well, while the results from the mouse models are incredibly encouraging, truly, as Professor Yankner said, some of the most dramatic data he's seen, it's absolutely crucial to stress a critical caveat. It's one the researchers themselves highlight, and one that sources like SBS News were very careful to report. You should not just start taking lithium compounds arbitrarily based on this.
Right. Don't self-medicate.
Please don't. What works dramatically in mice doesn't always translate directly and perfectly to humans. Rigorous, large-scale, randomized clinical trials in humans are absolutely essential. They must be conducted before any widespread recommendations can possibly be made for therapeutic use. That's just a non-negotiable step in the drug development process.
Okay. Human trials are key.
Absolutely. However, there are very positive indicators that might suggest an accelerated path, specifically for a lithium orotate. The mouse studies, remember, showed no lithium-related toxicity even after lifelong administration.
That safety profile seems really good.
It seems incredibly good. This low toxicity profile, especially at the much lower dosages required for lithium orotate compared to carbonate, could potentially allow for human clinical trials to be accelerated, maybe bypassing some of the initial intensive safety hurdles typical for entirely new chemical entities.
So maybe faster trials.
Potentially. The research team expresses clear optimism. They believe that clinical trials for lithium orotate, or perhaps similar optimized lithium compounds, could begin in the near future. And if successful, they could genuinely change the landscape of Alzheimer's treatment forever.
So cautious optimism, absolutely, but with a real sense of momentum, perhaps, given that promising safety profile. What are some of the key unanswered questions that still need to be addressed by future research as we move towards those human trials?
Well, one of the most critical unanswered questions, and it's a major focus for future research, is the exact initial cause of the decrease in brain lithium levels in the first place.
Right, why does it drop to begin with?
Exactly. While the study clearly demonstrates the deficiency and its profound impact, the precise trigger for this reduction remains unknown. Professor Yankner himself speculates about various possibilities. Could it be environmental factors, maybe dietary deficiencies in certain regions or exposures to something else? Could it be other subtle genetic factors that interfere with how lithium is absorbed or regulated in the brain? Or perhaps interactions with other medications or even lifestyle factors?
Lots of possibilities.
Lots of possibilities. He believes there might be underlying reasons why certain individuals begin to experience this crucial deficiency, perhaps even before plaques become really widespread. Furthermore, ongoing research aims to study lithium-level changes in people who don't develop Alzheimer's, but who might be at high genetic risk.
Comparing those who get it versus those who don't, despite risk?
Exactly. This would be instrumental in pinpointing specific target lithium levels that could be maintained for effective prevention. Identifying the optimal range before pathology takes hold. Understanding these thresholds would be a really significant step forward in developing precise clinical guidelines for prevention or early treatment.
Okay, understanding the cause and the target levels makes sense. This brings us back, though, to that patenting dilemma we touched on earlier. If it's a natural element and can't really be patented in the usual way, that's fantastic news for affordability and access down the road. But it might make it harder to get those big pharmaceutical companies to invest the, hundreds of millions, if not billions, needed for those expensive clinical trials, right? This feels like a really interesting, almost ethical funding challenge.
It is indeed the profound double-edged sword of this discovery, and it's a critical practical hurdle. The non-patentable nature of lithium is, as we noted, fantastic news for eventual affordability and widespread access. It helps ensure it doesn't become an exclusive luxury treatment. However, it presents a very significant financial hurdle for large-scale pharmaceutical investment.
Because there's no big payoff at the end for them.
Precisely. Developing and conducting rigorous human clinical trials spanning phase 1, 2, and 3 is an incredibly expensive endeavor. It often costs hundreds of millions, sometimes billions of dollars over many years. Without the prospect of exclusive patent protection and the associated high profits that incentivize such massive investments, private pharmaceutical companies may be significantly less inclined to bear that financial burden.
So who funds it then?
That's the question. This implies that government funding, maybe from NIH or equivalent bodies globally, public health initiatives, large philanthropic endeavors, or perhaps even innovative public-private partnerships might be absolutely crucial to push this research forward into human application. As Professor Hajek reiterated, underscoring the stark reality, such a safe and effective pathway for AD treatment, especially one that is incredibly cheap, is truly rare. It means the scientific community and public health bodies may need to find new, creative ways to shepherd such a vital, yet perhaps commercially unlucrative, discovery through the final, expensive stages of development. It's a real challenge of public good versus private profit motive.
It's almost like it's too good to be true in some ways, from a commercial perspective, even though the science seems so robust. And Professor Yankner himself, he offered a powerful analogy for this research, didn't he? A way to frame the magnitude of this discovery, even with the hurdles.
He did. And it perfectly encapsulates the excitement, the urgency, and the profound hope surrounding this work, while still being realistic. Professor Yankner stated that while we don't yet have the penicillin for Alzheimer's,
the magic bullet cure.
Exactly. That singular, universally effective, easily administered cure that completely eradicates the disease.
Hmm.
We don't have that yet. But he said this pioneering research brings us one step closer to developing such a revolutionary treatment. It's an acknowledgement of both the incredible progress made and the significant work that still lies ahead, but with a clear trajectory, a clear hope towards a genuinely transformative solution. And this raises an important question for all of us. Hashtag outro.
And that's exactly where we'll wrap up this deep dive into lithium's unexpected and frankly exciting role. Let's just quickly recap what we've learned today. Our journey started with that shocking discovery of a profound lithium deficiency in the brains of Alzheimer's patients. A deficiency caused, it seems, by those insidious plaques literally trapping this essential element, making it unavailable for crucial brain functions.
Mhm. And the meticulous HAVARD study, published in Nature, has really unveiled the profound and multifaceted role of lithium in maintaining brain health. Critically, it's introduced the promise of lithium orotate.
Right, that low-dose form.
This novel compound offers a broad-spectrum, low-dose, seemingly non-toxic potential treatment, highlighted by its ability in animal models to not only reduce the hallmark pathologies, the plaques and tangles, but also to dramatically restore memory and even prevent the onset of Alzheimer's.
Which is just incredible.
This research genuinely offers a beacon of hope. Hope for a future where Alzheimer's might actually be preventable, or at least far more effectively treatable, with an accessible and remarkably affordable element. It holds the potential to fundamentally shift how we approach cognitive health entirely, moving towards a paradigm where maintaining essential elemental balance is recognized as being potentially as critical as any other preventive measure in our daily lives.
So, consider this as you go about your day. If a trace element we consume daily, one that's fundamental to our planet's geology and has long been used in a completely different medical capacity, if that holds such profound secrets for our brain's resilience and longevity, what other simple, overlooked aspects of our environment and our own biology might be waiting to unlock solutions to humanity's greatest health challenges?
Interesting thought.
What other nutrients maybe are we underestimating in their power to prevent or even reverse disease simply because we haven't looked at them through the right lens yet? We invite you to think about the broader implications of treating disease through balancing these essential elements, and how this new understanding could reshape our entire perspective on health, nutrition, and our own incredible, complex biology. Thank you so much for joining us on this deep dive into lithium's surprising and incredibly hopeful role in the fight against Alzheimer's. We hope this has given you some new insights and perhaps a renewed sense of optimism for the future. Until next time, stay curious.